Hi everyone, in this video I am going to teach you on how to find the antiderivative of functions. And basically the functions we're talking about here are polynomial functions, rational functions, and then radical functions. But before I give you examples for those functions, we'll have a short review about the four fundamental theorems of antidifferentiations. Alright? And of course, I encourage you to watch that video if you haven't watched it. That's very helpful, and you really need to understand and at least master those theorems in order for you to better understand what we will be doing in our lesson for today. So this is the first theorem, the integral of x equals x plus c. By the way, again, that symbol that you see, we call that the integral symbol. This symbol. All right. So let's have an example for this one. Integral of negative 2 dx. So this simply is equal to negative 2x plus c. Right. Let's go to the next one. So integral of x raised to n dx, and that equals to x raised to n plus 1. So whatever the exponent is, you add 1 to that over n plus 1. And you notice that whatever is going to be the exponent here is going to be the same as the denominator. Right? Let's have an example. So the integral of x raised to 3, which means this is x raised to 3 plus 1 over 3 plus 1 plus c, and don't forget that c. So this is x raised to 4 over 4 plus c. All right, let's go to the third theorem. Now here the a is a constant or a numerical coefficient of the function or of this term. So we can take that out of the integral symbol. For example, this one. Now, maybe here in this example, it's not obvious which one is the numerical coefficient of x raised to 9, but it's actually 1/2. So I don't know if you thought about it, but it's 1/2. So that's x raised to 9 dx. So that's how we would write this. We applied the third theorem. And this equals to 1/2 times x raised to 9 plus 1 over 9 plus 1 plus c. Right? And the final answer is x raised to 10 over, so that's 9 plus 1, which is 10. You multiply that by 2, that will become 20 plus c. There you go. Okay, let's go to the fourth theorem. So here this simply means that we can actually separate each term in a given polynomial function. So we are actually now at polynomial function, and this is the fourth theorem is very applicable for um, our problem or our example for this. Okay, but we will apply that third theorem here. So I'm gonna write this one first. Um, Negative 2/3 x dx. So that's this. Then minus 8 x raised to 7 dx. That's this one. And then plus 6 x raised to 3 dx. That's this one. And finally, that's minus 1 dx. All right. So x is just equal to negative 2/3. We understand that the exponent of x here is 1. So we add 1 to that. That gives us 2. And whatever the exponent is, that's going to be our denominator. Minus 8 times x raised to 7 plus 1 is 8 over 8 plus 6 times x raised to 3 plus 1 is 4. Then we have, again, that's the same as the denominator. Then minus This is just x. And again, don't forget the c. All right, let's simplify our answer here. I think we can cancel that too. So our first term is x squared over 3. And I believe we can cancel out the 8 as well. So minus x raised to 8 plus, we can simplify 6 over 4. Both are divisible by 2. So that's 3 over 2. So that's 3x raised to 4 over 2 minus x plus c. All right, let's go to the next example. Okay, so here we have 2x minus 5. That's a binomial in square. You might be thinking, is there a different theorem for this one? Well, no. Unfortunately, for this, we need to expand 2x minus 5 square. Okay, if we want to be very specific with our answer. So which means we will apply the FOIL method. So 2x times 2x is just 4x squared. Then you multiply this. That's negative 10 times 2 is negative 20x, and then plus 25 dx. Right? So let me repeat the procedure. That's 2x times 2x, which is 4x squared. Multiply 2x and negative 5, that's negative 10. You double that, that's negative 20x. And then negative 5 times negative 5 is positive 25. And then let me just expand this. So 4x squared dx minus 20x dx plus 25 dx. Right? And this equals to 4 times x, 2 plus 1 is 3. Right? So I'm not going to show you that anymore, that 2 plus 1, to save some space and time. So minus 20 times x, there's a 1 there, so this will be 2 plus 25x. And our final answer is 4x raised to 3 over 3 minus the 20 and 2 can be simplified, so that's 10x squared plus 25x plus c. Here you go. All right, let's go to the next one. And here we have a rational function. So x raised to 4 minus x cubed minus 1 over x raised to 2. So what we can do here is we will apply actually that fourth theorem that we had earlier, that I discussed earlier, but we need to separate the addends here. Right, and we write this function. This can be written as x raised to 4 over x squared dx. So that's this minus the integral of x raised to 3 over x squared dx. That's this one. That's this two, the second. And then the last will be minus the integral of 1 over x squared dx. Alright, so we understand that this is going to be x squared, and this is going to be x, and this is going to be x raised to negative 2. So let me just write that, and I don't want to write everything. It's a lot of work. So remember, x raised to 4 over x squared is x squared, so we simply add 1 to that. That's going to give us x raised to 3 over 3. And then this is minus x squared over 2. And this is minus x raised to negative 1 over negative 1 plus c. So our final answer is x raised to 3 over 3 minus x squared over 2. This is going to be plus now, and we want the exponent to be positive. So this will be equal to 1 over x plus c. There you go. All right, let's go to the next one. And we again have a rational function. Now, if you encounter this one, the first thing that comes into your mind is how are you going to separate the addends here, the x cube and then the x minus 2? Well, you can't. Well, you can actually do that, but um, it's going to be like really a long method. But my advice is if you encounter this kind of problem, remember that fraction is division. So my advice is maybe we can divide that polynomial on top, that's x cubed minus 4x squared minus 3x plus 14 by x minus 2. Not going to using the long division. I will be using the synthetic division. So if you're familiar with that, my advice is do that first. And let's maybe we can divide this, right? So to do the synthetic division, I'm gonna bring down all the coefficients of the numerical coefficients of the numerator. That will be 1, -4, -3, and then 14. And let's see if we can divide this. Divided by 2. That's x minus 2 equals 0, so x equals 2. Bring down the 1, multiply that, that'll be 2. Then add -2, multiply -4. We add -7. This is -14. Oh, there you go. So since the final number here is 0, that means we can divide the 2 and simplify the entire rational function into a simpler polynomial. So this is actually x squared minus 2x minus 7. That's the problem now that we will be dealing. Okay, so that would be the integral of x squared dx minus 2 integral of x dx minus the integral of 7 dx. So this will be equal to x cubed over 3 minus 2 times x squared over 2 minus 7x plus c. And so our final answer is x cubed over 3 minus x squared. We can cancel this out. Minus 7x plus c. There you go. All right, let's go to the next example. And I think this time we will be having a radical function. So in a radical function, what we need to remind ourselves here is how to convert a radical into an exponential term. Okay, but first, let me just do this. That's theorem number 3. Take out that 7. All right. And now that fifth root, by the way, that's not 7 raised to 5. That's the fifth root of x squared. So I'm going to convert that into exponential term. So the index, that 5 is the index, will become the denominator of the fraction. Now remember, our fraction here is going to be our exponent rather is going to be a fraction. So this is x raised to 2 over 5 dx. Then we just need to apply that second theorem. So this is 7 times x raised to 2 over 5 plus 1 over 2 over 5 plus 1. Alright, let me just simplify this 2 over 5 plus 1. So that's 7 rather, times x. So 2 over 5 plus 1 is 7 over 5. So this is 7 over 5 also, right? 1 can be converted to 5 over 5 so that they will have the same denominator. And then you add 5 and 2, that gives you 7. All right. Don't forget the plus c. Let's include the plus c. So now this is going to be equal to 7 x 7 over 5, right, times the reciprocal, because this is a complex fraction here, the reciprocal of 7 over 5, which is 5 over 7. And as you can see, we can cancel out the 7 here, and that's going to give us the final answer, which is 5x raised to 7 over 5 plus c. There you go. Okay, we are down to the, I think this is the last example. Okay, so first let's distribute this x squared to each of the three terms here on the right side. Now what I'm going to do is I will convert that x, or square root of x rather, into x raised to 1/2. Just remember that. Okay? And then I'm going to apply theorem number 4, and I will separate each term. So now this is going to be x squared times 2x raised to 1/2. That 2 is going to be outside now of the radical integral symbol, or integral sign. And then x, so 2 plus 1/2 is 5 over 2, right? 2 plus 1/2 is 5 over 2 dx plus 10 x raised to 3 dx minus 3, and then x square dx. And this is equal to 2 times x raised to 5 over 2 plus 1, 5 over 2 plus 1, plus 10 times x raised to 4 over 4 minus 3 times x raised to 3 over 3 plus c. Alrighty, so let me just change this. So that's 5 over 2 plus 1 is equal to 7 over 2. So let's just put 7 over 2 here. There you go. So reciprocal of 7 over 2 is 2 over 7. So that means multiply that 2 by this 2, by that 2, the big 2. So that'll be 4x raised to 7 over 2 over 7 plus, I think we can simplify this. So that's 5 over 2. So 5x raised to 4 over 2. Then we can cancel this out, minus x raised to 3 plus c. So there you go. That's how you find the antiderivative of polynomial function, rational function, and radical function. So I hope you learned something. Thank you for watching, and have a nice day. Bye.